I just want to give you a taste of some of the videos that you'll find in the Solidworks surfacing episode on the Design Stuff site. The model I'm going to use for this demo is a most recent boot demo that I created. It's maybe not as complicated as it looks. First, I'm working in and out of a certain mode with the feature tree. The mode that I'm using is, if you right-click on the top name, go to Tree Display, Show Flat Tree View. What this does is it just shows everything in the order it was created. You might say, well, that's what it normally does, but no, it really doesn't, because if you create boundary surface, for example, it will show the sketches that were used to create the boundary surface underneath the feature itself, where those sketches were actually created before the boundary feature. And you'll notice I've also got another setting turned on. You can turn that on or off again from the top of the feature manager. Right click and you see the dynamic reference visualization. You have a setting for relationships that go up the tree and relationships that go down the tree. Up the tree are parent features, down the tree are child features. Let's set this back to the way it was. Tree display and turn off, show flat tree view. Another thing you should know about this model is that the result is a combination of solids and surfaces. When you look at the surface bodies folder, I've got a lot of surface bodies, and I've got actually several solid bodies as well. When we take a look at the finished product and how I arrived there, you'll understand why those things are the way they are. Okay, so let's use the rollback bar and just get started going down through. I'm going to use the setting in Tools Options, Feature Manager. There's a setting in here called Arrow Key Navigation, and when I use the cursor to manually move the rollback bar up or down one, then I can consequently use the arrow keys on the keyboard to move rollback bar up or down until I've done something else, and then I have to go back and reinitiate that mode by manually using the rollback bar. Anyway, so the first thing that I've done here is I've created a couple of planes. I called them inboard and outboard. I'm sure you can, there are more technical names for shoe design, but I created a loft that represents the sole. Now, this is obviously not the shape of the sole, but remember that SolidWorks and NURBS in general likes to work in four-sided surfaces. So I created a four-sided surface, and then I trim it to shape. And that trim was just done with a planar spline that goes all the way around. Could have used a spline on surface, would have been another way to do that. Now I've got a feature misnamed here. This boot top split was not really the boot top split, but the boot, we'll just say it's the sole split. Because what I've done is I put a split line across the heel, and this helps me to make the built-up heel on the boot a little bit easier. And from here, I go ahead and create the boot top faces, which is again renamed. So notice this is a solid feature. The first loft was a surface feature. So I'm already combining solids and surfaces. Let's rename this. I'll call this the heel. From here, I'm going to go ahead and thicken the sole. Let's watch this happen from the side. I'll thicken it to the top side for a couple of reasons. For one, to keep this edge consistent with the heel, and also because I've already established where the bottom is, I want to bring everything away from the bottom as I build the shoe. This is one way that you can create an offset. Normally, you would take this and you go it on the say the top plane. You would offset the edge all the way around it to the inside and then project that back on. But that can be kind of inaccurate, especially when you have curved surfaces. So one way to do it, and this is relatively new and probably hasn't gotten a lot of publicity, is you start a 3D sketch and you select the surface, and then you find this tool, Offset on Surface. I've put this one on my sketch toolbar. What this does is it offsets the edge of the surface in one direction or the other. So let's initiate the command. It will go so far, but you can notice it's pointing to up here, and that's saying that it's that's the point of minimum curvature, probably the point where it's going to first fail. Okay, now it fails at 0.4. That's just because it went past the minimum curvature. The biggest offset you can have there is 0.3. Now this is a 3D sketch, and it will turn out to be a spline in your 3D sketch. And it's got a dimension on here that you can change. You don't have to go back to the dialog box to change that. Now we're taking a look at the boot top feature, and you can see that there are only really two profiles. There's a top profile and the bottom profile, but SolidWorks lists three. Let's take a look at why that is. If we edit this feature, we've only got two profiles in the list, but the first one is a closed group. And here's how that was done. If I delete that selection, this closed group consists of items from two different sketches. These were selected using the Selection Manager. Selection Manager allows you to select either a subset of a larger single sketch or items from multiple sketches. So in this case, I'm selecting this curve from one sketch and this curve from another sketch, and then hit the OK button. And SolidWorks sees that as a single profile. There's something that's a little bit odd going on with this. It lists these as three separate sketches, even though they're really just two different profiles. Usually, SolidWorks allows you to roll back between the feature and the sketches to temporarily unabsorb those sketches. But when we do this in SolidWorks, we get a really odd result. The rollback bar just goes away, and the sketches that we're looking for aren't here. So that looks to be something that happens fairly frequently in SolidWorks with new features, is that there's some of the odd functionality that they haven't totally worked out. You just have to be aware that things like this will happen and be able to work around it. The way I work around this one is I just right-click on anything and pick some sort of function that relates to the rollback bar. For example, roll forward, roll previous, and we get our rollback bar back. Okay, so that's how the top of the boot was created. It's kind of a simple thing, but there are a lot of little details in how you can create things like this. From here, I created a split line that was a silhouette split line that creates edges on the front and back, because I want to build this boot, half of it at a time. I don't want to build the whole thing at the same time. It makes it a lot easier, especially since it's not symmetrical. I have some additional planes that I needed to make for cross sections to control the boot. Then I had to make some control surfaces or reference surfaces. I make these a lot of times. I use them instead of sketches. For example, on the front of the boot shape, I created a spline for that, but then I created an extruded surface as well, because I can create a tangent relationship to that surface that holds true throughout the feature. I did the same thing for the heel, and I did something down at the bottom using that 3D sketch with the offset that we created earlier. I also created a ruled surface, which is like the extrude, but it's at an angle. I could have gotten this probably by applying a draft to the surface, but I chose to do it this way. The next feature of real consequence is the outboard toe section, and this is a fill surface. We take a look at this section. It's a three-sided area that's very three-dimensional, and it was created in part by a sketch which is essentially a cross section around the foot. Also, another constraint sketch that I added. And then portions of the ruled surface and the top extrude surface. Before I open up this feature to see how it was created, I should probably show some of these features that were used as reference. So I'll show the top extrude, show the ruled surface, I'll show this sketch and this sketch as well. And then I'll hide the solid that's behind it because we really don't need to see that. Okay, now let's go back and edit the fill surface feature. The first edge was an edge of the extruded reference surface, and that was set to tangent. The second edge set to tangent is the ruled surface that was angled at the bottom. And part of the reason that was angled is so that you could get a little bit of a flare on the width of the shoe at that point. And you can increase this flare by changing the angle of the ruled surface. The third sketch in here is the cross-sectional sketch created to help give this all some shape. And you remember there was another sketch that I used in this feature, the front constraint sketch. What this does is, without this feature created a little bit of an odd shape in the front. So we can take this out, and now it's not giving us the odd shape right now. It's easier to visualize these things when you turn on the curvature display. So you turn on the mesh preview and jack up the mesh density setting, and you can see this is a little bit flat here maybe. So adding this as a constraint curve, it doesn't have to match up with the UV mesh. Solidworks will make it lie on the surface. So when I add that, it rounds out the curvature a little more, and everything just works better. Don't forget about using constraint curves with your Solidworks fill surfaces. Very often, it's the difference between making something work and needing to find some other workaround. So now we can hide these surfaces. Again, I'm using either clicking from the graphics window or the feature manager, but you can also go up and use the surface bodies folders to do this. If you have a big monitor, and I'm using a reduced resolution here just for making the video, you can split your feature tree and just use the folders up at the top, while down at the bottom you're working with the other features. So that makes selection sometimes a lot easier. I'm just going to use a single feature manager at this point. Also, if you get adept with using the breadcrumbs, these can be a very significant aid in making selections. In any case, let's keep going. The outboard front is just the piece that covers the ankle in between the top of the boot and the front of the boot. And from here, this is kind of interesting. Let's take a look at this. Notice that I selected this edge and this edge, but there isn't really any break on the edge in order to only select half of the edge. So let's clear selections and do it again. I'll select this edge, and I select this edge. Now, this is no good because it doesn't get the heel. And if I were to put the heel in here, it would just mess everything up and it wouldn't work properly. So what I'm going to do is I'm going to use these connectors, these two pink dots, and I'm going to pull these back about halfway. The nice thing about these is that you can be kind of approximate. You don't have to be really precise with these. You can just kind of use them visually. And I went about halfway on both sides. Okay, so that allows me to loft just half of it, and I can continue on. Now, if I were going to also do this back side, then I'd have to do the same thing, but I'd have to be more precise, and I'd have to get that connector to line up exactly right on that. So I don't want to do that. What I'm going to do instead is use a knit. And I'll knit together the top of the boot, this front section, and the toe area. And what that does for me is that when I go to select this now, all I get is that portion of the edge. So knitting the faces together affects the edges, and now I can go ahead and create the ankle. Since the ankle is a really odd shape, I'm going to use the fill surface to create this. And the fill surface uses this top edge, this front edge, this lower edge, and it also uses a portion of the ruled surface that has been hidden. It's not there right now. And also the edge of this back surface that was extruded. That's also been hidden right now. Now, since we're talking about the fill surface here, I want to talk about a couple of these settings. In particular, optimized surface. Optimized surface is, you notice if I click it, it really doesn't do anything. The only time optimized surface is going to do anything for you is when you have a four-sided area. It will align the UV mesh with the four-sided area. What we have right here is a five-sided area, and you see that the UV mesh is not in any way aligned with anything. So SolidWorks is making a larger patch and then trimming it in to fit. The fill surface is a fantastic tool for an area like this where everything is trying to fit together in an odd boundary. Notice that I use curvature on almost everything except for contact, which was at the bottom. That was because I really didn't need to control curvature there. Between the toe area and the heel area, it was going to give me the angle that I needed. And also I just set a tangent at the back because it's just an extruded face, and the difference between tangent and curvature back there, the curvature will actually kind of flatten it out a little bit, where tangent will allow it a little more curve. Let's proceed on to the next feature here. Inboard sole extrude. On the other side, we're starting to go through the same process. And from that extruded surface, I also created a ruled surface, and then the front inboard for the toe, and we're going through pretty much the same steps as we went through for the other side of the boot. This move face is kind of a random feature that's been added here, but what this one did was I used this to thicken the sole a little bit. So if we move this, roll this back, notice that gets thinner. And then move face is what they call a direct edit sort of thing, although it's a history-based feature, so it really can't be direct edit. But if we look at the feature, there's an option in here to offset, so you can see where the sole was and then where it is now if I offset it by 1/10 of an inch. Okay, let's take a look at what this trim is about. This trim is the boot trim at the top, so we could rename this top shape trim. And then I created an offset of those top faces, and then another offset. At this point, what I'm starting to do is starting to create some of the interior and exterior features of the boot. In the course of rolling this back and making changes, I've done something that upset the balance of this offset surface. So what I'm going to do is go back to the original and go to File, Reload, and say, okay. SolidWorks will try to talk you out of it. And then I can come back and find where I was and roll back. Now when I roll back this second offset, it shouldn't fail. Okay, so what I've done is offset a little bit for a lining on the inside, and then a little bit on the top for a fold over. So I can do a flap trim, and that gets this fold over. And then what I've done is with this surface loft, I've actually lofted from the inside to the outside of the boot, and instead of trying to be tricky and make that smooth, what I did was I came back later and put a couple of fillets on that. So now it kind of rolls over nicely. This might be better if I use the edge display shaded with edges. That helps you see what's going on with the model a little bit better. Then I wanted to put my emblem, a little Z, on the back here. And to do that, the first thing I did was I created an offset surface. Oh no, here I'm making... This is why you name features, because this should be the toe silver offset, and then I trimmed that back, and I made the toe and heel silver trim. And maybe I fixed the name of this one, and so it's toe and heel. Okay, and then each one of those was thickened into a solid piece. Like they'll cap parts of boots in silver. Okay, then we put a little fillet on here. Now I want you to notice something here, is that I did this in a single feature, but that's because when I used the thicken actually merged into the sole and the heel. So if I look at the solid bodies and I click this, then the toe and the heel have merged to become one with the sole and the heel. And for that reason, I can apply a fillet to both of them. Let's just go back here and mess with something. I turn off the merge result so that this thicken feature, which is for the heel, does not merge with the sole. Okay, and to prove that, we can go up here, and now we have two solid bodies. Well, you might have noticed that something's gone wrong with this fillet feature now, because you can only fillet edges from a single body at a time, and that'll become important later on. So if I hit Control Z for undo a couple of times, or if I just go back and turn on merge result, so now our fillet works on both the front and the back because everything's merged to a single body. Okay, so now I'm going back to trying to make my Z back here, and I've offset a surface, changed the color to red, and then I trimmed the surface that's in front of it. So you can see here with the shadows that that there's a surface back in here, and that trimming out the orange surface makes that red surface visible. Okay, so that's a little bit on how the 3D effects on this boot were created. You might want to take this a step further by thickening the outside of the boot. If you're working with surfaces and solids at the same time, you really need to be careful about things. So in the course of the rest of the boot is really just offsetting sections and trimming away sections. And that's all that this decoration is. It's just trimming from either the side of the boot or the front of the boot. You'll see a lot of thicken features in the tree, and that's because you can't thicken multiple bodies at once. You have to have one thicken feature for one body, one surface body. So you notice that I left a few of these unthickened. This surface body was thickened. You can see that there. But this surface body was not. You can see it just kind of hanging out there. It's just left as an example so I could show that sort of thing. All of these little circles that I left in here These are all just surface bodies. They haven't been thickened. So that's how this boot was created and kind of the decision process used in making it. And several of these types of videos are found in the surfacing episode site. Thanks for watching.